My name is Nora Gourmelon, and I'm a PhD candidate at the Pattern Recognition Lab at the Friedrich-Alexander University in Germany. That's true. Yeah, I won the AI Newcomer Award in the Natural and Life Sciences. That position is given to two persons. So this award, me and a fellow colleague from, I think she was from Darmstadt. Yes, and that award is granted to young researchers under the age of 30 for innovative work in artificial intelligence. So I've worked in several projects so far, and for me, the most interesting part is, of course, the research that I'm doing currently for my PhD, and that is about the recognition of the calving front, so the position where an glacier ends and the ocean starts. And for that, I'm using deep learning techniques. So I'm using segmentation. So I want to do segmentation, and I use so currently we have actually a first transformer approach. Before I had been using an optimized UNet. Yes. Then in another project, I'm working together with the German Federal Agency of Nature Conservation, where we want to automate the process of counting birds in aerial videos. And there we did a first study on whether that's possible to recognize birds in those videos, not by hand, but automatically with a neural network. That actually worked well. And another project, so that's actually a lot of things that I've been researching on. So the last thing that I was recognized for was the research that I did during my master thesis, where I handled smart water meters, and I got time series information there. And I showed that it's necessary to have labels to do classification because clustering did not work based on that data.
So
I'm the most proud about the work I'm doing right now with the calving fronts, so with the glaciers. I have put, I think, the most effort in those because I've been working on it now for 2 years. And yes, we published a benchmark data set there, which is really nice, and some baselines. And we are now having very many new ideas. We want to go into the direction of uncertainty. And yeah, I can talk a long time about it. I actually always prefer to talk about the technical details. I mean, I'm a computer scientist, but of course, I can tell you what it is for. So for the calving fronts, it is actually, this position is a very important parameter in glacier models, which are part of climate models. And if we have this position and can automate the extraction of it from satellite data on a reoccurring basis, then it will be more accurate. And in the climate models, they will also be more accurate than in the end. So we will better predict the future climate. And we will know what to prepare for. So for example, the IPCC reports rely on those climate models. Of course. Actually, we have worked on several models. The latest one that we got published, that one focuses on the post-processing. So we have like the UNet that I used before that I implemented a year ago or so as a baseline, but we could improve that just by putting in a conditional random field afterwards as post-processing. That smooths out the edges and gets rid of some errors. Yes, and then also one other one that got published, I think it was this year, There we use a hook net. I'm not sure whether you've heard of that. That's two connected units, one that gets a global view and one that gets the smaller patch. And we optimize that by integrating attention mechanisms into the hooking, so the connection between the two units. Yes, that's actually one thing. I would like to emphasize that science is a team sport, and that I would not have been recognized for my work if I did not have all the great people around me. My lab, my supervisor, maybe we can name him by name, Vincent Christlein, and yeah, so that was quite fast. I can also write that to you. And Vincent Christlein, he's called, and also Thorsten Seehaus from the geography department.